Hi, future doctors. Welcome to the next class. In this class, we will discuss about frictional force against to the vertical wall. So, coefficient of friction is mu. If you place an object on the vertical wall like this, how it will be moving means it will be moving downwards because its weight is going to act downwards. If we are applying some amount of force in this direction, this is applied force. Then this wall will apply normal reaction against to this wall. Whenever it is at rest position, normal reaction is balanced by applied force. Now, who is going to balance this weight? This weight is going to be balanced by frictional force developed between surface and object. This is going to be frictional force is equal to mg whenever this is at rest position. If we are removing this force F, little bit less force if we apply, this object will be moving downwards. Now I will show this object, just you can see. If this is the plane surface, I place like this. This is the object. So now I am applying force with finger like this. If I am removing this finger means it will be moving downward slowly, correct? So whenever you are pressing like this object, now how much force? This weight is going to be balancing. So object weight is going to be balanced by frictional force in upward direction. So this surface will apply normal reaction away. I am applying force like this. So same thing, you can press a book against to the wall. You will be getting idea what I am saying. You will be getting. Now whenever you got here frictional force, we came to know frictional force is equal to mu n is going to be equal to mg. Now, what is n here? Normal reaction we wrote F equal to mg. Now, very important formula F equal to mg by mu. If you are applying this much force, object is at rest position. They will give mass, they will give mu. How much force we have to apply, they will ask. At that time, you have to use this equation. Now, if you are removing this force little bit, less force you are applying, then this object will move downwards. Whenever object is moving downwards with acceleration A, frictional force is acting upwards. Now, what is the net force? Net force is nothing but mg minus F. So, mg minus what is frictional force equation? Mu n. Mg minus mu. What is normal reaction here? Applied force. That is going to be ma. Now see what is the acceleration of this object which is moving downwards means mg minus mu f by m. A is equal to g minus mu f by m. So this is the acceleration of this block if it is moving downwards. When it will move means if you apply less force against to the wall. Now this object is placed in between two walls. Now what is the force we have to apply to not to move this object? At the time, whenever it is going to be F, here we have to apply two forces. Therefore, now in this case 2F is equal to mg by mu. Simply F is equal to mg by 2. This is going to be applied force. In the same case, they will ask, a vehicle is moving. Car, lorry, auto, or bus, any a vehicle is moving. On this vehicle, an object of mass m is going to be placed. This vehicle is moving in right side direction with force F equal to ma. So now on this block, equal and opposite force is going to be applied. That is equal to F equal to ma. This surface will apply normal reaction outside. Its weight is going to be balanced by frictional force. Now, same question, F is equal to, whenever it is at rest, with how much acceleration this vehicle should move, they will ask. How much acceleration vehicle should move means F equal to what we have to write? F equal to ma. So ma equal to mg by mu. Then a is equal to minimum acceleration is g by mu. Understood? So minimum this much, otherwise it should be greater than. A should be greater than or equal to g by mu. This vehicle is moving with this much acceleration, then this object will not fall downwards. Will not fall downwards. What is the condition they will ask? At that time you have to use this equation. So very simple, you can take one object here. Whenever we are taking one object, you are against to your hand. So whenever we are taking this object will fall downwards. To not to fall, how much acceleration we have to give? So we are moving this object like this. How much acceleration we have to give to not to fall this object downwards? So that is the case we are going to get to not to fall downwards acceleration. Next, if a cylinder, if a cylinder is rotating, washing machine, anything you can take. Whenever cylinder is rotating, all the objects which are at center will be moving against to the wall because of centripetal or centrifugal force. So M mass. So centrifugal force will be acting like this. Normal reaction by the wall will be acting like this. Again weight is acting downwards, frictional force is acting upwards. What should be the minimum angular velocity to not to fall this object downwards? They will ask. So all the cases, same equation. Fc equal to. Here, see, in this case, how much force we applied here? How much force we applied means mg by mu. Same equation you will get here. Fc equal to mg by mu. So on the vehicle, this F we provided in the form of mass into acceleration. So in this rotating cylinder, we have applied in case of, means for rotating cylinder, centripetal force is required. This centripetal force will provide on this object in the form of centrifugal force, it will be moving away. If we switch on the fan will rotate because of centripetal force. On the fan, if you place any object on the wing of the fan, that object will move away from the fan because of centrifugal force. So this centrifugal force formula, we have three equations total. mv square by r, mr omega square, mv omega. So whichever you want, depending on the question, you have to write mg by mu. Here they ask what is the minimum angular velocity, omega they ask. Therefore, we will write mr omega square equal to mg by mu. So if you cancel masses here, you are going to get omega square is equal to g by mu r. Omega is root g by mu r. This is angular velocity. If they are asking velocity, then you have to take this one. M v square by r is equal to mg by mu. M cancel means v square is gr by mu. Therefore, v is root gr by. So all these are vertical surfaces. So if you aware of this, f is equal to mg by mu, the remaining all you can do. If it is there on horizontal surface, how we have to take? One small change will be coming. So we will see those in next class. Thank you.